Alright, let's examine the given graph. Let's state the domain of the function. Well, the domain of this function, x belongs to all real numbers, but we can see that there is a break in the function. There's a vertical asymptote at -1, so x cannot equal -1. Okay, so restriction on the domain is the vertical asymptote. We're going to see how this factors in when we assess continuity and we look at our limits. Now, evaluate the limit for the graph. Let's start with part 1. Okay, I'm going to say f of x here is equal to x squared over x plus 1, so I don't have to keep writing it. So let's take a look at limit as x approaches -1 from the right side of f of x. So from the right side of -1, so when you're looking at this from the right side of -1, you can kind of relate -1 from the right side as -0.99999, right? And if we're looking at -1 from the right side, we're basically approaching the vertical asymptote this way, right? So this is 1 from -1 from the right side. And you can notice here that as we approach -1 from the right side, because there's a vertical asymptote, the graph won't actually hit -1. It'll basically keep going, and I'm just going to use a different color for this. It's going to keep going until it reaches positive infinity. Right? As you get closer and closer to -1, the graph will just keep extending, right? Because that's what an asymptote is. So this actually goes all the way to positive infinity. Okay. Now let's take a look at part 2. We're looking at -1 from the left side. Okay. So looking at part 2, limit as x approaches -1 from the left side. So this is the left-handed limit, right? So this was here the right-handed limit. This is the left-handed limit. And the left-hand limit, basically, we're looking at -1 from the left side, so we're approaching the vertical asymptote this way, right? So as you're approaching the vertical asymptote this way, if we look at our trace, we can see that the trace is going to keep going down, right? And eventually, the trace will just keep going. It will never touch -1. It'll go all the way to infinity. Okay? So the way we'd want to write this is going to give us infinity. Okay, so off the bat you can notice that the left and right-handed limits are not equal to a finite value, right? And they're also equal to infinity. So because the left-handed limit and the right-hand, because the right-handed limit is equal to positive infinity and the left-hand limit is equal to negative infinity, right? Both of these cases don't exist. It doesn't exist because it's not a finite value, right? In part 3, we have limit as x approaches -1 of f of x, and we can understand that f of -1 here, according to the limit property, doesn't exist because f of -1 here is basically x squared over 0. Right, and whenever you have a numerator over 0, the denominator is a restriction and it won't exist, right? So this actually doesn't exist either. And similarly, f of -1 is basically -1 squared over -1 plus 1, which is 1 over 0, which doesn't exist. Okay, so because the right-handed limit, the left-handed limit, the original limit, and f of -1, the function itself, doesn't exist at x equals -1, then therefore f of x is discontinuous at x is equal to -1.